So now that we have seen what are all the different types of parameters and hyperparameters given or are present in a given neural network. So we have weights, biases, hyperparameters, the hyperparameters such as a number of layers, number of neurons in the input, hidden layers, etc. So now that we have seen all these things which are all present in the given neural network, now it's time to follow certain representation or denotion denoting those parameters, right? So we can just keep calling or keep referring things like fifth layer, fifth input, or second layer, first input. So we can't keep doing this when it comes to a large network structure, right? So for a simplification purposes, we will just follow a certain representation or uh, what do we call identification of individual parameters and the hyperparameters in a given neural network. So let's start with a notation for the parameters in the neural networks. So these are all the standard notations which we will follow throughout the study of the neural networks. So coming to the very first one, that would be weight. So weight of a given neural network will be represented as W, and it will be in the form of matrix. So unless and until I mention or represent it as an individual value, all the things which we discuss or denote over here would be a matrix form. So this is the ground rule. Okay. So all the notations which we provide over here would be representing a vector. Vector are also called as matrix. Okay. So the weight would be represented by W and it is a matrix. B shall stands for a bias of a given layer, right? Okay, bias is present within every given layer. So what do we know about bias? Bias is the threshold for a given layer or a given neuron, what we can say, uh, by crossing which the particular neuron will get activated, right? So then comes X, stands for the input of the given neural network. Okay, there are numeral number of inputs that we can pass into the neural network at a time, and we'll have a discussion on that as well. But as a whole, the input to the neural network will be represented as X. Then comes Y. Y would be the ground truth or the actual output of a what do we call output of a particular problem. Suppose if in case we have, if you want to classify the or if you are following a classification topology, then we will be having 10 classes, right? So 10 classes are the output classes. So we want to classify the input signals into one of those 10 classes. So why will be those 10 classes? Those are the actual outputs or the ground truth label, which we can call it as y. Then comes P. P is the probability vector of the predicted output. In other words, what we can say, it would be representing the probabilities coming out from the neural network. So it will be the output probabilities from the given neural network. Post activation, or once we can say, as a given classification problem, we will be predicting the probabilities of the input signal belonging to each and every class, right? So those probabilities will be represented by P. Then comes a not but not the least, that is H, that is output of the hidden layers. So as we discussed, given a neural network, there will be an input layer, output layer, and in between input and output layer, there will be a number of hidden layers. So output of those hidden layers, it might be individual or collectively. So all those things, the output of the hidden layers is represented by letter H. So again, to reiterate on the fact that all these things, all these notations are represented as matrix until and unless we have a subscript or a superscript for them. So what would be subscript and superscript representing? So we'll make that decisions, or we'll make that ground rules here itself. So a superscript represent any of these parameters or any of these notations represented by a superscript represents or stands for a layer number. So if I represent W to the power of 1, that represents weight associated to the layer 1. Suppose if I represent B to the power of 1, then that represent the bias for the layer 1. So similar way, if I superscript any of these things with the number, then that will be the representation for the particular layer. Then comes the subscript. Subscript is the one which we denote at the bottom, right? So subscript stands for the index of the individual neuron. Suppose if I say x1 2, that represents individual input to the first neuron. So x11 represent the input to the very first neuron in the input layer. X12 would be representing the input to the second neuron in the first layer, right? So the x1, the subscript x1 represent the layer as well. So 1 represent the very first neuron, 1 2 represent the very second neuron of the same layer. So subscripts represent to the index of the individual neuron in a given neural network. So to be very sure and to be very careful, I will reiterate on all these things again once again. So W is the weight of the matrix, B will be the bias for the given network or a given layer, X stands for the input, Y stands for the ground truth or the actual output of the uh, network, and P be the probability output or the probabilities of the output coming from the neural network, H will be the hidden layers or the output of the hidden layers. Superscript represent the layer number and subscript represent the index of the individual neuron. So in the next session, we will be having in detail representation of these parameters, taking an example of a neural network.